Lesson 11.2 and 11.3, Solving One-Step Inequalities. So our goal is to understand the similarities and differences between solving inequalities versus solving equations like we looked at in class. And just like our discussions and exploration figured out for us in class, is that really there's only one difference, that inequalities can be solved just like equations, except the only difference in solving inequalities versus equations is that multiplying and dividing an inequality by a negative reverses the values of the inequality. In other words, positives become negatives and negatives become positives. So everything reverses and flip-flops. So to compensate for this, you must also reverse the inequality symbol, but only in this situation, anywhere I multiply or divide by a negative. All right, so for an example here, here's this inequality. Right now, negative 3x is less than 39. Notice how this side's negative and this side's positive. So if I go to solve this, my move would be to divide by negative 3 to counteract this multiply by negative 3. These cancel, but now this side's positive and this side's negative. So I went from this side being negative and this side being positive to this side being positive and this side being negative. So there's no way this inequality symbol is right anymore. So what we want to do is we want to flip-flop that symbol. We want to make it x is greater than negative 13. All right, and so that's our answer. And of course, we graph it. Put it on a number line. Don't forget negatives. We kind of have to go reverse here. All right, and so not equal to negative 13, but anything greater than negative 13. And if I were to try out some numbers, we'd find it works. Like let's try negative 10 right here. If I plug in negative 10 into the original problem, negative 3 times negative 10 is positive 30, and 30 is less than 39. If I try 0, 0 would be way over here. Negative 3 times 0 is 0, which is less than 39. And so because I counteracted this flip-flopping change by changing the inequality symbol, everything still remains correct. All right? So here it's just a matter of remembering this one special situation for inequalities. So when you do problems like these, hopefully you treat them just like equations except for that one extra rule. Here, n minus 12, I'm going to add 12. All right? But adding doesn't do any of this flip-flopping we've been talking about. So we would do this just like a regular equation. We just drop the numbers down. Notice how I did not change the symbol. And so all I have to do here, is graph this, and I'm done. Sorry for the sloppiness of my numbers. This tablet's a little hard to use. So less than or equal to 49. Here's equal to 49, a closed dot, and everything less than that. Let's take a look at this one, though. Negative 4 times k is less than 24. So the move here would be to divide by negative 4. What I do to one side, I do the other. Now, what I recommend is that anytime you have this special case come up, I just divided both sides by a negative. I like to star the problem to remind myself there's something special going on here. And so when I make this move, k, all by itself now, it reminds me that because I just divided by a negative, I need to flip-flop the symbol. So k is now greater than negative 6. So there's negative 6, not equal to negative 6, but anything greater than negative 6. All right, let's try the next one. H plus negative 3 is greater than 14, so the move here would be subtract negative 3. What I do to one side, do it to the other. These cancel, and I get H. Now, I am dealing with a negative here, but I'm subtracting with a negative. I'm not multiplying or dividing, so once again, this does not fit our special case, so we just do this as normal. 14 minus negative 3 is 17. Notice how I did not change the symbol. And then I graph it. H is not equal to 17, so open circle, but it's everything greater than 17. All right, and how about this last one? Let's take a look here. W divided by negative 5 is greater than or equal to negative 30. So the move here would be to multiply by negative 5. And what I do to one side, I do the other. And this does fit our situation. I just multiplied both sides by a negative. So over on this side, these cancel, but this side is now positive. This flips, to counteract that change. And this side, which was negative, also becomes positive. All right, so because everything flip-flopped, I have to flip-flop the symbol. So now I can graph it correctly. So W would be equal to 150 or anything less than 150. All right, now let's talk about one last thing. Now I've written one of the sentences down again. Once again, our exception, the thing that we keep starring, is anytime we multiply or divide an inequality by a negative. And this wording is really important because I've had people do problems like these too. And you know what, let's not even worry about the graphs right now. We're just going to get rid of those. Let's just focus on the problems. So here I'd have somebody, they'd see, oh, 4 times n, I'm supposed to divide. They'd do this cross out here, then n. And then what would happen here is they would get confused, and they would see that negative 20 divided by 4, and they'd see, oh, it's a negative, and I'm dividing. So that must mean I flipped the symbol. Okay, but if you look up at our wording up here, it says we're multiplying or dividing an inequality by a negative. We're dividing by a positive 4. Even though there's a negative involved, this doesn't fit our definition. And so in this case, this is not a special circumstance, and we just leave the symbol alone. Leave it as less than. Same thing here on this problem. D divided by 12. The opposite move is to multiply both sides by 12. These 12s cancel. I get D. This becomes negative, I have no idea. Let's work it out. 48, 576, negative. Okay. Now, it's a negative 48 being multiplied by positive 12. Again, people make the mistake that, oh, I'm supposed to flip the symbol. But I'm not multiplying by a negative. I'm multiplying by a positive 12. So this does not fit our situation. We leave that inequality alone. Okay, so this is just something to be a little bit careful about because this does happen quite a bit, and you really have to stick to the exact wording of our rule here. All right, so that's a little bit about what we've discovered in class and just getting it down in our notes. Multiplying and dividing by a negative reverses values. So because of that, you have to reverse the symbols.